Welcome everybody to my talk about untangling test code. I'm Micha. I come from Germany, from Cologne. I work for Øredev, which is, you may or may not know, the second biggest supermarket in Germany. Supermarkets are strange. They don't go over borders for some reason. I don't know why. But discounters, of course. And I've been working at Øredev for 10 years now, and we are doing microservices. It's all nice and tidy most of the time, but eventually a service is like 4 years old, and then you didn't touch it for a year. It was running well, right? And then you get a new requirement, and you try to implement that. And I don't know if you know that, but test code can be really mean to us when we try to change something. I wrote that test code myself. I was passionate about testing, about test automation. I thought, yeah, I want to, I make a change, I run the tests. I'm 89% sure this won't cause a problem. But still, that test code sucked. So why does the quality of test code matter? Or let me switch that question around. Why doesn't it? Because what we do in test code, we would never do in production code. And this talk will be about that, about the sins that we do in test code that we would never do in production code. And I wonder why that is. So if anybody has a question, an answer to this question, why we are so sloppy with test code, I would be interested to chat about it. So I've been thinking about what is good test code. And one of the most fundamental things is test code is just code. We cannot act like we don't need to maintain it, because we do. Otherwise, we could just not write it, and we know that doesn't end well, right? Or is there anybody to object? Okay. So what's considered bad in production code, we should not do in test code. Simple as that. Also, for test code, I think, additionally to what's bad in production code, is that it's very important that we can see the intention of the test very clearly. We should not guess about this, right? Has anybody ever come back to a test that you have written, like 2 years later, and you were flabbergasted what that test was supposed to do, why it is here in the first place, and how the hell it's working? Well, I think the most terrible thing is that when you really end up guessing what your intention back then was. Its functionality should not be obscured. I already spoiled that one. Basically, you look at the test and it fails, and you really don't know why. It just fails, and you don't get how that test is technically set up. Its results should be meaningful. I spoiled that as well. So basically, when I have a failing test, I should be immediately knowing what's wrong. If this is bad, if this is okay-ish, because I just made a change, and this test was supposed to fail because it basically described the previous way it was working. I don't know. And failure causes should also be easy to find. That sounds like the same thing, but it isn't. So when I add a lot of abstraction to my tests, which would sometimes solve the first problem, I can obscure the failure causes. There's no command click and I'm right where the error began, but it might take me some time to click through all the abstraction layers. And its maintenance should not be hard. Yeah, okay, that's the same for production code, I guess. Okay. So the first untangle I want to say, because I will refer to this for the whole talk, and I realized, okay, we need to talk about this. Anybody knows about arrange, act, assert? Yeah. Anybody doesn't? Okay. given when then. Yeah, so it's the same idea basically. We have three parts to test. We have one part where we set stuff up. We have one part where we interact with the unit under test. And the final part is to verify what happened. The first part can be omitted sometimes if we don't need to set up a lot of things. So in a lot of unit tests, let's say we test a method that adds 2 integers. Yeah, well, there's not much to set up, right? And also assert and act can sometimes be one line because we just call a function and immediately check the result. But this is a good structure. And I would go so far to say all of these could be roughly one thing. One thing that's, I will get to that. I don't think I need to explain it now. But this structure is just a good way to structure your tests. Sometimes you will be tempted to add a second act and a second assert. Don't. Okay, hidden arrange. Hidden arrange is when a test relies implicitly on certain things that are happening outside of the test. Here's an example. This is Java. I hope you can abstract from the language if you don't like Java. Nobody really does, but everybody knows it. So I figured it would be okay to present in Java. So this is a Spring Boot test where we fire up a whole microservice and then just call the API to check if it does what it should. Right. So first we have this REST template, get for entity, and we just call some URL and expect a string as a result. Okay, fine. Then we do some assertions, and one assertion is, okay, it should be an HTTP status okay. Well, fine. The body should be JSON, apparently, because we're using an object mapper to read it, okay. And the body should not be null, well, fine. Body is an array, well, and its size should be 1. Why 1? Why not 0? It's nothing up here. It's just we initialize that object mapper and we inject the base URL, and up here are some annotations that don't give us any information. Anybody knows how this witchcraft happens? You can put a script in your project which needs to be in source test resources and should be named something like anything.sql, and it will be implicitly executed before your test run. This is convenient. I was delighted to find that feature once. And by the way, it's fine to set up your schema something, but don't add data through that mechanism, because right now, let's say, okay, we need something more than this one unicorn in our database. So we change that script to have 2 unicorns. And now this test will fail for all the wrong reasons. So don't do this. So hidden arrange validates some of the properties of good tests, in my opinion. It obscures the functionality. And there are additional failure causes that we don't know about. And we cannot reference the data that was implicitly added to the database. What we can do about it is something like what I call a test data manager. There are several ways of implementing this. Basically, we take this test, it's still the same, and we just add this. So this is a test data manager, as I call it. I call clean, which basically means truncate all the tables. I don't want to have old data in the database right now. If another test ran and put something in it. And with one unicorn that I have in my test. And now I can, and this is the test data manager, and it's basically using a database connection and uses basic SQL again to just put data in the database. And clear is truncate table. So this way we have through this parameter here, we have full control of what's in the database in any test case. We can now also test there's nothing in the database. Maybe in that case, we expect something different than HTTP OK. Maybe we can test if there's too much in the database, something like that. So now we have full control, and we can also reference the data that we put in the range block in the assert block, which is usually a good thing to do. So this way, we have a clear intention, because we wanted, in the arrange block now, there's one unicorn in the database. You don't need to state that in the name of the test. It's just obvious. There's one unicorn in the database. The next test case may be something like empty database, a special case, where we just say test data manager clear. So we are not relying on the test name, but we can just look into the arrange block to figure out what's different, what's special about the test at hand. And that's the underrated property of arrange blocks, that it tells me what's different. Lots of tests are very technical in arrange because they are considered just setup. Right. Magic values. Anybody familiar with the concept? I think so. So basically, there are literal values like 42, 23, 123 within your code without any hint why they were chosen. Sometimes we use values like 123 and think, yeah, that will be obvious that I just picked any integer. Well, sometimes it's not. Sometimes it was important that it is above 120, for example. Or it was important that it is below 1,000. We cannot see these properties when we are facing magic values, because they're magic. So here we see something. This is the smallest, most terrible test that I ever written. I wrote this myself, and it was not for the sake of a bad example. I really did it. So it is pretty easy, right? You have this unicorn object. It has a bunch of properties. It's a real simple record class, so nothing special about it. It does not even have proper methods to it. And I'm just calling the constructor. Okay, random UUID. Well, that doesn't matter, I guess, obviously. Well, does it? Maybe it needs to be random, right? Because there's already something in the database, and if I put another thing with the same UUID in the database, it would fail. I don't know. Gilly, yeah, probably not important. I don't know. Main color red, well, I guess that's random. 111, yeah, that sounds random, whatever. And now here we have 62 plus 1 day, and here we have 61. Is there a relationship? I mean, it's not that hard to figure out that there is one, but it leaves me guessing. And maybe this is a mistake. Maybe here it's supposed to be minus days or something like that. So it's really not that obvious what's important here. I need to go through all these things, and it leaves me guessing what this means. Yeah, and then Micha added highlight steps and forgot about them. So this is a bad practice in production code. It's also a bad practice in test code. For some reason, this is the most common thing people do anyway. I don't know if anybody has an explanation why magic values are considered okay in test code. Let's check. I guess it's just for the sake of coming up with examples quickly, but yeah, still it's bad. Also, it obscures the intention sometimes, as I just said. Why was that value chosen? Is there some property to that value that I cannot see? And the functionality can be obscured by magic values sometimes. And maintenance is hard, especially when there is some hidden property in the magic value, and that changes. Because then we have to go through all the tests that are using the same damn magic value and update it. So, how Oh, right. Yeah, somebody forgot about his structure. Another thing the same example basically says is this is a long arrange. These are quite some lines. I don't like it. So if the next test would be, let's say, 62 years old, without the plus days here, there would be a lot of lines that would be the same, and then that one line that differs. So this is bad. As I just said, arrange blocks should be an indicator what's different in the test code. And if I have a lot of boilerplate lines, this obscures the difference. So the intention is no longer immediately obvious. So what we can do is we can just, as Richard yesterday also suggested, we can just use the builder pattern. Anybody familiar with the builder pattern? Okay, it's pretty common, right? So in test code, we can just replace this one with this one line. So, well, it could be one line, but I like to put it on several lines. And now we are only explicitly setting the date of birth. So the next test that has another example, oh, I used another example, I just realized, would be obviously different. And the test data builder has some properties that are just set constant, some that are random, but with explicit properties. For example, here, 1 to 101. And it has some modifiers. It had an initializer and some modifiers, so it can change whatever I need to change for a certain test case. And then I can build it, and this is now the only place in my whole test code where this constructor is being called. Meaning, if I add another property to that object, I'll probably only need to go into this builder and all the tests will be fine. Probably I need to add some test cases, but I don't need to revise all the other test cases that do this. Right. So this way we have a very clear intention because we shorten our arrange block to the bare minimum, the one that really differs. And maintenance is also way easier because now we have a centralized file where we have all the example code and the properties that these example data should have. I used Instancio, right? Instancio is really great. It basically gives you a generic way to have these builders, so you don't need to write them yourself. To be honest, I came back to write my own builders because it felt right. But if you have really, really huge data objects, especially if you have data objects that have complex properties, like a unicorn having a sub-object, and you need to fill all that data as well, it really sucks. And Instancio, you just say, Instancio, give me an instance of class, and it will give you an instance that is filled. Like if it's a list, there will be a list with 20 elements or 21 elements or whatever. Yeah, check that out if you have that problem with huge data classes, like more than 20 properties or something, then that really makes sense. Yeah. By the way, I'm fine with you asking questions in between, so go ahead. I like it. Right. Long technical act. We already saw that these are quite some lines of code, right? So this again is a test that would post a unicorn as a JSON object to the API, and will then do some assertions. Sorry, I have a cold. This is quite. I don't really care about this header right now. It's a technical detail. I'm not really interested in it. Also, this URL, if I change the API URL, I need to update all the tests that basically have that same code. So this can also be a maintenance burden. And the functionality, well, the functionality is pretty obvious because we're just calling the API as we would do it in production code. But yeah, well, it's too much detail, right? So what we can do is an act helper method. So I call it act helper. You can also call it actor. So what I can replace this with is one class that I call front-end act helper, because what I'm doing here is I'm acting like the front end would act. And so I decided to put all the methods that are behaving on behalf of, like the front end in reality, I would call them front-end act helper. This is quite nice because it puts one more nice information into this test, namely what are the components that this is important for. So if this API was broken, my front end would be broken. That is what this line also tells me. And in that, we have the same code we had before. So pretty easy. Forgot to set my timer. Okay. Sorry. Okay, so now we have a way better intention. And we also have an easier maintenance because, again, we have a centralized class where we keep, for example, the information how we come up with a base URL. Questions? Okay. Long assert. Basically, it's a lot of things that can get long and confusing in tests. And long assert is the other side of it, basically. So here we have, now we are using a builder. This is nice. We only need a standard unicorn, which is interesting. We don't need any special properties. We use a test data manager to clear our database and put that one unicorn in. Then we use the front-end act helper. Nice, get unicorn. And now we have this. Huh. Why? Okay, so why is this dangerous? Any idea? So one thing is dangerous, that I will not read this because it's basically a wall of text. I don't want to read this. I will assume that these are all the properties of a unicorn. Spoiler, they aren't. There's one missing. And I will also assume that this is not important. This is just an equals, basically. It's a sophisticated equals. Like I put the JSON in, and I just I get JSON out, and I can now compare it with a unicorn that I put in the database in the first place. That's what this intends to do. But that intention is not there. Maybe there was one value that I changed for some reason. I don't know. Maybe this was +1 for some reason because the unicorn got older or something like that. I don't know. And also, failure causes aren't easy to find in that case because we have a lot of potential errors, and now we need to figure out why has that value changed. I'm sorry. So what we can do, again, is a helper method, or a helper. And in this case, an assert helper. So instead of this, I shortened it a bit because the code got too long. Instead of this, we can use the assert helper, and the assert helper assert equals. And now these aren't the same object. This is a string, and this is a unicorn object. But I don't care. I will just implement this the same way the test before looked. But now my intention is obvious because I want to check if this is equals. Right? Okay. I don't. Good. Somebody paid attention. Yeah, so the other solution that I did not put in the slides is you could use approval testing. Anybody familiar with approval testing? Yeah. So approval testing would take the string, the JSON, and it would put that JSON for the when you run the test for the first time, it will put that JSON into a file, and that file will be, I don't know what the postfix is, but you can find it then in your test code. And when you change the postfix to approved or something like that, the next time the test runs, it will only compare the result against the previous result. So you will have a nice diff that you can see, this is missing and this has changed, and now you have a nice diff that everybody will understand. This line has changed, this line has changed, right? And now you are definitely checking all the values, right? So this is really a good thing, especially when you have huge data objects. I would point you to approval testing instead of this. Right.
So the failure process is still be difficult to find, right? Because it changes the way that you measure norms into features and everything.
Mm-hmm.
Then that could be the one that caused the failure, and then wouldn't it be difficult to find that it was this exact pattern?
Yeah.
I was just wondering because you marked out that thread before.
So yeah, you're right. The failure cause is still hard to find, but it didn't make it worth either. Yeah, you're right. I should not have marked that.
Why are pretendable linked to Is that because there are too much repetition?
Very good. In the back. Yeah, that would also be an option, like creating something that would take the JSON and try to construct a unicorn out of it, and then you can simply use equals. Yeah, that would also be a good option, I think. Some people, it is debatable if it's a good idea, to be honest, because sometimes that's not possible. Sometimes there's something missing, or it's not directly convertible, and then the failure would be in the construction of the comparison unicorn instead of in the test. So I have it on the cheat sheet, I think, that I will show you later. But yeah, it's debatable. So something like that. Anyways, try to get away from this block of assertions and try to express your intent. This is the goal. I don't have a perfect solution, to be honest. Approval testing is quite close, but approval testing again, then you have that comparison file that's somewhere. Also not ideal, I think, but way better when you have really huge result objects. Okay. So make your intention clear. What do you compare? Is it an equals comparison, or is it maybe a diff towards what you put into the database before? I don't know. And also, it might put less code scattered over your whole test space, right? This is my favorite thing in this presentation, because usually a lot of people don't like it. Test case names. Who likes to name test cases? Okay, what's wrong with you? Okay, yeah, well, in some test frameworks, you don't even have to. I think RSpec, Richard, it's RSpec, you don't even put test names. Yeah. Okay. Well, there are test frameworks where you don't really have to name tests, but in Java you have to. So Here, so it was all the time in all the examples, it was kind of a microaggression that I put really randomly named tests in there, like no pattern at all. So here, test HD not given results in 500. Last time I checked, this wasn't a 500. So, and also not given, well, it's 0. It's not given, in my opinion. So, how did this happen? Most of the time, I copy-pasted a test case. I kind of updated the name, but I didn't pay much attention. And also test case names. I mean, if you put everything in there, they are going to be that long, right? So, yeah, let's leave it like that. But this is a problem because it leads us to the wrong conclusions, right? We might think, is the name wrong or is the implementation wrong? That's not a good place to be in. So here in unit tests, you might have something like this: H works here too, H works here also. I mean, I'm exaggerating, I think, but I found something like that. And in API tests, we might have get, unicorns, works, and returns non-empty list. It's not interesting. I will probably never read that. I will probably never update it, so it will be wrong eventually. Right. So the problem is the intention is now obscured because I have two different sources of truth. One is the actual source of truth, that's code. Code always says the truth. I like code. The other one is the comment, the name, which will lie eventually. Results, this is really important because the test case names will be what ends up in the test report. So it can really put us in the wrong position because we thought, oh, this is broken. But it wasn't. It was something different, and we just copy-pasted the name. And maintenance, well, if you have this long test names, it's really hard to maintain them, so we don't. Okay, so why don't we use consistent and concise test names? And I put an emphasis on concise. Because I think the longer a test name is, the more formal it is, the less I like it. Or the more work is it to read it, like understand, okay, what's the difference between these two test cases, because they're both named this long. And the other thing is, I need to update that all the time, right? So what's important information about a test case? I think it's the unit under test. So in Java, this might be class plus method name under test. The expected behavior. So do I expect it to fail? How do I expect it to fail? And the state under test. Anything missing? Okay. There are several patterns that use these or similar words. I think there's one that splits the state under test up into two, but it's basically this. So now we can come up with a pattern like class under test test. This is pretty standard in Java. This is what most people do, and I don't object. But this way I can tie a test case directly to code. And then test method under test should expected behavior with state under test. Do you like that? Still quite long, isn't it? Okay, how is this? Method under test underscore state under test underscore expected behavior. Better? I like this way better. Okay, let's have this. Method under test underscore state under test. And we just omit the expected behavior. Why would I do that? Because it gets way too long. The expected behavior is already described in the code. Just read the damn code. Why would you put that in this, right? I mean, if you have a test and it is the exact same thing on the test, the same unit on the test, and you have the same state on the test, why do you need to specify the expected behavior? It must be the same, right? Because these are the inputs, basically, and this is only the output, the expected behavior. That's true. Yeah. Yeah, the intent is not in the name. Maybe not too cool. Maybe the intent should be in the name because the intent is not in the code. I was discussing with Richard, and I think he has a point. But, well, I don't know how to express the intent properly. So here's another example. What did I do? Ah, yeah, right. Test counter. So this is maybe a bit extreme. Just say test 1, test 2, test 3. Well, at least it won't be lying, and it wouldn't be annoying to name tests. That's true. Yeah. So the report will be pretty useless. So my favorite one is this. It does not express the intent, but it's concise. When I sort my test cases, I will have them sorted by unit under test, which I like a lot. I don't specify the state under test when it's the happy case. I just name it after the method that I will call. This does not express the intent. It does not solve that problem. But it's easy. It is, in my opinion, it makes it really easy for me to find a specific test case. And one danger I see when you have really long test names is that you rewrite another test case because you didn't realize that it's already there. I did that several times already. So if it's that concise, it's very unlikely that I didn't see that before. So as I said, I put an emphasis on concisiveness, not on correctness or on the missing intent. Yeah, it's missing. But I think the state under test can be somewhat expressing the intent, especially for unit tests, where everything is rather technical, right? So, okay, so let's apply that to the unit test. So hworks becomes hbirthday whole years ago. hworks year 2 would be hbirthday years plus ago, and so on. So now I have this. Now I have the special cases all figured out, and I can sort them, and I see everything's about age. Usually in unit tests, it would be only one word, or it would be camel case. Right? So and the rest is basically a sentence, and I like to have proper separators there. But you can come up with something else. So you can say, okay, I will camel case and I put the separator only between parts. It's, to be honest, this is pure taste. Do whatever works best for you. I just want to suggest don't make it as correct as possible. Make it as short as possible. That's so. By the way, the idea for it is coming from Chris Beam's article on how to write commit messages, because commit messages also get way too long, and it's really hard to find the right one. So I think he had a point there. And for the API test, we can do something like get unicorns, get unicorn, post unicorn. So it's pretty easy to find that as well. This is just one suggestion. My main suggestion is find one that is good for you and apply it to your whole test suite. Don't do campsite here, just sit down for an hour and rename all your tests, because otherwise you have all these broken windows everywhere. Sorry. So intention can be a bit more obvious now, especially you don't have two concurrent things that would tell you what the expected result is. And maintenance is also easier if the test name is really short. Okay. I nerded over, I don't know how many pages, 10 minutes read. This is an article by me where I put way more effort in telling why I think that method is good. And we're almost out of time, I guess, right? Okay. So the last thing I only want to tease you here, you will get the slides right away, is behavior over specification. And what I really mean is the usage of of mocking frameworks. Don't do it. Just stop doing it. I know this is a lot of debate that we can put in here, but mocking frameworks, try to use them as little as possible, because when you change your internal APIs, mocking frameworks will make you specify that internal API, and refactoring becomes really, really hard. So recently I have seen James Shaw's article of testing with nullables or testing without mocks, and I just want you to try it, because this really, really made the maintenance on our test suite so much easier, because we didn't need to update all the mocks. That was just great. It is a bit confusing for Java developers, because James Shaw is always coding in JavaScript, and JavaScript is so what, not Java. Okay, so if you like to apply this to your own test suites, in the background you can see a folded paper. That's my cheat sheet that I created from this talk, where you have the tangles and the untangles, and you can apply them. And if you like the slides, they are behind this QR code. Thank you very much.